Now, let's look at the difference between compounding period and payment period. Okay, let's use an example of you making a loan with the bank. Okay, normally the bank will give you some rate, the interest rate, for example, say 8% per year, compounded semi-annually. So the compounding period is semi-annual period, or 6 months. Every 6 months the interest will be compounded. Okay, but you have to repay the loan to the bank on monthly basis. So that monthly payment is known as payment period. So exercises after this will look into detail on how we can calculate or analyze the cash flow when it involves compounding period and also payment period. Okay, so we will be looking into several cases of payment period and compound period. In the first case, when it involves a single payment or single cash flow, and when the payment period is more than the compound period. The second case is when there's annual series involved. So the payment period of that annual series is more or equal to the compound period. The third case, again, when annual series are involved, but when the payment period is less than the compound period. Let's look at the example. This very simple question asks you, what is the amount in your account after 5 years if you deposit a one-time amount of $10,000 at an interest rate of 1% per month. So given that the compound interest period is different, as in monthly, quarterly and yearly. In order to solve this problem, let us first draw the cash flow timeline. Okay, we want to calculate for 5 years, kan? And we know that is a one-time deposit at present year, which is $10,000. So we want to calculate what is the corresponding F value, the future worth at year 5. So if the interest rate are known, okay, this should look very familiar to you, then you can simply calculate the future worth by multiplying the present worth with the FP factor. Okay, but in the case of effective interest rate, there are certain restrictions that you have to follow. The first one is that the I in this formula must always be the effective interest rate. Okay, the second one is that the N in this formula must always be the same time unit or with the effective interest rate. Okay, let's look at how we can solve this. In order to illustrate the effect of compound period on our timeline, let us first draw the 12 months time period or the 1 year time period. So we know the $10,000 deposit happened at year 0 or at month 0. So 1% interest are being charged for 1 month. So the question asks you that if the interest are being compounded monthly, then we can draw the compound period using blocks as shown, and we will have a total of 12 compound period for 1 year. Okay, now let us extend our timeline up to 5 years. Kenapa 5 years? Because we want to know the value for 5 years, kan? So at year 0, there is a one-time deposit of $10,000, and then we want to calculate what is the future worth at year 5, remember? Okay, now we know that for 1 year, there are 12 blocks. So I'll just redraw the compound period in blocks like this. So the 12 represents the number of compound period for 1 year. So the total compound period for 5 years would be 12 multiplied with 5, and we will get the compound period to be 60. Okay, so now substitute all the values in our FP calculation. The present worth is $10,000. The FP multiplied with the FP factor with the interest rate. Our effective interest rate for 1 block is 1%, so no problem, no need to convert or whatever. And then our N is 60. Okay, the total compound period is 60 for 5 years. And then we just look up for the FP factor in the compound interest table, and we will get the future value of $10,000, which are compounded monthly, to be $18,167. The second question is not so simple. This time, dia tanya, what if the interest are being compounded quarterly? Pula dah. Anyway, I love to visualize this by drawing the timeline for 1 year first. Okay, so we know the 1% are being charged for 1 month. And then if the compound period is for quarterly period, so we have to have 4 equal blocks in 1 year. Okay, as shown, 4 equal compound period. Okay, and then we have to look for the effective interest rate for one compound period or one block. So if you remember from our RM equation, we need to identify what is the R value and the M value. So the R value in this case would be 1% plus 1% plus 1%. We'll get a value of 3% or 0.003, while our M is the number of bloop in one compound period. So our M is 3, and we will get the effective interest rate for one compound period is 3.03%. Okay, now let's extend our timeline across 5 years. Okay, and we know that for 1 year there are 4 compound period. So kalau untuk 5 tahun adalah 4 compound period for 1 year multiplied with 5. So that is a total of 20 compound period. And then you just substitute this value in your equation just like previous solution, and you will get a value of $18,167. Okay, so you notice the I% is actually the effective interest rate for one block or one compound period, whereas 20 is actually the total compound period that you are calculating. Okay, so I hope you get the idea on how you can apply the effective interest rate and also the number of compound period in solving for a single payment kind of thing. Okay, so why don't you try the third part of this question on your own? And this is the final answer. Okay, see you in the next episode.